the third episode of Climate Change Committee's podcast.
Today we're interviewing Dr. Betsy Stoner, an environmental science professor at Bentley University.
Hi, ladies. Thank you for having me. I'm Dr. Stoner, and I'm an assistant professor at Bentley University, as Ashley said. And I'm really excited to talk about climate change today. My background is in marine ecology. And so broadly, I'm really interested in how human activities affect coastal marine and estuarine ecosystems. But specifically, my work sort of centers on understanding jellyfish blooms. So how climate change, so warming ocean temperatures, but also nutrient loading, habitat modification, all of these things that humans are doing to the oceans may actually stimulate the populations of jellyfish that we have globally. So a lot of my work focuses on trying to understand how jellyfish blooms may occur in human impacted environments, and in turn, what effects those jellyfish blooms have on the ecosystems that they're blooming in.
All right, so our first question we have for you is, what inspired you to get into your field of study?
For me, there was a lot that sort of pushed me in the direction of marine ecology, but I would say that one of the biggest things that happened was I was probably about 8 years old, and we were on a family vacation. I grew up in central New York, but we were on a family vacation in Florida. And I remember walking on the beach, and on the bottom of my feet, the soles of my feet, by the end of the beach walk, they were caked in these tar balls, these like big clumps of oil. And I was so disgusted and I was so confused, where was the oil coming from and what was happening. And so I had a really long conversation with my dad, who worked in the environmental field. And basically he was like, most likely this stuff came from oil spills. And so really starting to understand the ramifications of human impacts in the marine environment and sort of the implications for not just marine organisms, but also for people too, right? It comes back to bite us. So I really started getting interested in the marine world, I would say, after that trip, and just sort of started reading more about marine ecology. We had the benefit of going to Florida every year on vacation, so really trying to expose myself more to what was going on in the oceans.
Have you traveled anywhere that's benefited your research or your studies?
Yeah, so I would definitely say the Turks and Caicos was a big one for me. That experience was really incredible because when I was there, one of the components of that study abroad trip was doing this directed research project. And one of the key fisheries that's in the Turks and Caicos is spiny lobster and also queen conch. These are foods that are commonly consumed, and they're exported typically to the United States, actually. And so at the time, we were doing this tour of a processing plant for conch and spiny lobster. And I had noticed that there were these big grates on the floor of the processing plant that just dumped out into the ocean. And so everything just sort of got pushed out. So all of the guts from the animals would just get pushed out, as well as human waste as well. And so for this directed research project, I became really interested in getting a better handle on what was happening to all of that waste. Where was it going? Was it having any sort of ramifications on the local ecosystem? So that was a pretty pivotal experience for me, because basically that determined what I have now devoted my life to. So that was a big one.
All right, so our next question, you mentioned that you focus on studying marine life, and a big issue that affects marine life are microplastics. So we were wondering what microplastics are and why are they bad for the environment?
Yeah, great question. So this is actually something that we're doing a lot of work on right now at Bentley. My research lab is doing a lot of stuff on microplastics actually in jellyfish. So microplastics are teeny tiny little fragments of plastic, tiny little pieces of plastic. They're 5 millimeters or less in size. And microplastics can either be sort of unintentionally created. So if you have a big plastic, I'm trying to find a piece of plastic around me. Okay, if you have a big plastic like this card, and that plastic starts breaking down into smaller little plastics, that's a microplastic. So they can be created through, if a bigger plastic enters the oceans and salinity, so the salt can break it apart, or UV radiation or wave action, it can break the plastic down, right? And so a lot of microplastics are created that way through the breaking off of bigger plastics. So microplastics are now everywhere, right? Like 80% of all marine litter is plastic. And there are millions and millions and millions of metric tons of plastics entering the oceans every year. So we know that plastics, microplastics, are invading all marine organisms. They are affecting every single level of the food web, right? Everything's encountering them. With microplastics, really the literature is, it's increasing. There's a lot more than there was, but we're still trying to get a handle on exactly how harmful microplastics are for marine organisms. The same sort of thing can happen with physical gut impaction with microplastics. We also know that plastics are very sticky, like microplastics are really sticky and they have pitted surfaces. And contaminants that float around in the water really are sticky too, and they like to stick to plastics. So those contaminants can stick or adsorb to the outside of the plastics, and effectually the plastics become these little poison pills because they have the contaminants stuck to them.
So what would you say is the largest source of microplastics in the ocean?
So the largest source of plastics generally is from land. That's sort of probably not very surprising, but most of the plastics that enter the oceans are from land-based sources. So things like stormwater runoff, okay, that carries plastics from streets and from, city streets and all of that sort of stuff into water bodies that ultimately end up in the ocean. And then there's a lot of plastic that just sort of gets, that's just litter that gets blown around and enters water that way. So most of the plastic that is in the ocean is from land.
So we know that microplastics are really tiny, but are there ways we can remove them from water, or is it completely impossible?
It's such a good question, and it's not impossible. So there are some really cool, innovative organizations that are working on plastic removal. So the Ocean Cleanup Program is one. They're doing very cool stuff. They deployed this really neat, it's almost like a vacuum cleaner, like a giant vacuum cleaner in the ocean. So the Great Pacific Garbage Patch is essentially this giant floating, mass of microplastics. You can't really see the plastic. It's all teeny tiny, but it's there. And so Ocean Cleanup Program has devised this tool to basically sit out in the Great Pacific Garbage Patch and just hoover up microplastics. And then they have this conveyor belt that sucks up the plastic. And then every now and again, a ship will come, they'll pick up these giant bins full of plastics and cart them back to shore.
So what are some of the biggest factors that contribute to pollution in the ocean?
We humans use so much stuff. We have so much stuff, and we tend to use a lot of materials that were sort of designed to be used once and then we throw them away, you know? So single-use plastics, that's a really big problem. Those are things like your plastic grocery bag, or, you know, your plastic straw, or your plastic Starbucks or Dunkin' Donut cup, right? Those are single-use plastics. They were designed to just, you use them and then you throw them away. And the problem with that is that it creates so much excess waste, right? And so all of that excess waste has to go somewhere. And ultimately, unfortunately, a lot of it ends up in the oceans.
So this is more of a general question, but a lot of marine life have been dying due to debris and waste in the oceans. So what are some potential consequences if marine ecosystems completely collapse?
Basically, the biggest consequence that I can think of is that we as a species happen to be at the top of food webs, right? So, you know, over a billion people, for instance, rely on marine ecosystems. Closer actually to 3 billion, I think, at this point, rely heavily on marine ecosystems for their primary source of protein from fish. And so if our marine food webs start to collapse because so many organisms are heavily impacted, not just by microplastics, but by, you know, everything else, climate change and ocean acidification, um, humans are really negatively affected at the end of the day, you know? And so that's a very, very big concern.
So to change the topic more to climate change, how has global warming essentially affected the oceans?
Oh, yeah, in a very big way. I would argue that even above microplastics, and that's a huge pervasive problem, global climate change and rising sea surface temperatures is the biggest problem that is facing the oceans right now. It's the biggest challenge. It's having a huge impact. You know, we know that temperatures are rapidly increasing in a lot of oceans, right? And the oceans basically have single-handedly thus far saved our butts because so much heat is absorbed by the ocean, because the ocean does such a great job at taking our heat. I think there's some statistic out there that like every minute, one atomic bomb's worth of heat energy is absorbed by the ocean. So the oceans are really saving our butt. Our planet would be fried if it weren't for the oceans right now. But because they're taking so much heat, um, things are just heating up at such a fast rate, and that's having huge cascading effects on marine life, on even on dissolved oxygen, right? It's affecting our ocean's ability to retain dissolved oxygen. It's affecting our ocean's ability to take up more CO2, right? Which is kind of important. So big issues.
So this is kind of a follow-up to Ashley's question, but how does climate change affect pH levels in oceans?
We know that climate change and we know that ocean acidification are both being driven by elevated greenhouse gas levels, particularly in this case, CO2, right? Climate change, we know that's really affecting like ocean temperature, but ocean acidification, so that's what you're referring to, Delara, is with the pH, right? So we're seeing that basically because of all of the CO2 that we as humans are producing through burning fossil fuels, right? Um, all of that CO2 that's being generated in the atmosphere, like roughly 30% of that is going into the oceans. And that CO2, when it hits the water, it forms something called carbonic acid. So it's this really weak acid, but it's an acid. The acid that's being created by CO2 is starting to effectively gobble up the calcium carbonate in the oceans. And so it's becoming more and more acidic. The big problem being that creatures that rely on calcium carbonate, effectively limestone or chalk that need to make their skeletons, like stony coral or shellfish, right? They have calcium carbonate shells, or even things like squid. Squid have calcium carbonate inside of them. Fishes have little bony discs inside of their heads that are made up of calcium carbonate. So many marine organisms need calcium carbonate for some reason. And if all of that's gobbled up because of all of the acid, basically, that's in the ocean, those critters can't create calcium carbonate any longer.
Are there ways that we as humans can help sustain marine life? And if so, then how?
It's such a good question. And yes, we can. So a big one is probably the hardest to do, but it's the most important, and that is to really stop consumption as much as we are in terms of like greenhouse gases, right? So that means reducing our consumption of fossil fuels. That means really thinking more critically about the amount of resources that we consume that would contribute to climate change, and producing more CO2 that would contribute to ocean acidification, right? Thinking, at least in a more manageable way about our consumption and how much we feel that we need to consume of things that maybe, we don't necessarily need as much, like single-use plastics. That's one, I think, really attainable solution, right?
So you talked a little bit about traveling, but have you participated in any experiments or projects that have helped you collect research? And if so, which ones?
I had the opportunity to collect jellyfish from various parts of Florida to see if they were, obtaining microplastics. So that was really cool to be able to go to a bunch of different systems in Florida and collect jellyfish. I can tell you, you get stung a lot. If you do jellyfish research, you get stung a lot. So that was awesome. And that definitely, that whole study allowed us to really very closely understand how microplastics might affect jellyfish. We don't typically think much about jellyfish as being sort of important in the food web, but they are. They're really important food for a lot of different critters. So if jellyfish are ingesting a lot of microplastics, thinking more long-term, like how might that affect the marine food web again? So that was really cool.
How do you think that younger generations can prevent the negative effects of climate change on the environment?
I think there are so many ways. I mean, for starters, this is kind of amazing, you guys. So great job. Just educational outreach, right? Getting people to think more about climate change, getting people to think more about consumption and how they're, the role that they can play in climate action, right? That's a big one. Really talking with people about making sure that they're voting, making sure that they are really like taking an active role, whether that's in your local community, right, politically, or maybe, helping others campaign for political causes that are really focused on climate change and climate action. I think that's a really big one.
So do you have any final thoughts or closing comments?
I guess just I would say like keep it up, one, because again, this is amazing. And I think this is so awesome that you guys are doing this. But I think like one of the things that is really important to remember is you, the individual, can affect environmental change, right? You can. And yes, these are incredibly massive problems, and there are a lot of layers to them. But I think that what we're starting to see more and more of with like the Greta Thunbergs of the world is that every individual can affect change. You can do something to make a difference.
All right, that's all the questions we have for you. Thank you so much.
This was so fun.
Thank you.